Okay, this video we're going to do some examples with both Lagrange and alternating series error. This first problem is in your notes, if you have me for a teacher, it's in your notes. So what we're going to do, they give you the derivative or the formula for the derivative of your function, and then they want you to write the fourth degree polynomial. So basically, this is your derivative. Okay. This is your derivative, the formula for your derivative. Okay? Now we're told that f of 3 is 1/3, so we're going to start with 1/3. And then we're putting in values for n equals 0. So I'm sorry, n equals 1. So at n equals 1, we get -1 to the nth power, 1 factorial over 5 to the first power, and then 1 plus 3. So when n is equal to 1, that gives us a derivative of 1 over 5 to the first power plus 4, times 4. Okay? Remember, this is my derivative. So then, and it's negative because it's to the -1, so it's negative. So my derivative is -1 over 5 to the first power times 4. And remember, I have to, this is my first derivative, so it's divided by x factorial, or 1 factorial. So when n is equal to 2, my derivative is -1 squared, so that my next term is going to be positive. And then n factorial is 2 factorial over 5 squared over 2 plus 3, which is 5. So after a while, I kind of see the pattern. So this is going to be positive, so I can see that it's always going to alternate. And so I have 2 factorial over 5 squared over 5, and then this is going to be over 2 factorial. What did I forget in this? I forgot my x minus 3 because it's centered about 3, and this is x minus 3 squared. Okay? Now I'm starting to see the pattern, so I'm going to do the next one without actually using the equation, the formula. So the next one is going to be minus 3 factorial over 5 cubed times 6 over 3 factorial. And I am writing a fourth degree, so one more. 1 plus 4 factorial over 5 to the 4th, 7 over 4 factorial. Now this simplifies to, just going to write the simplification over here, 1/3. This is minus x minus 3 over 5 times 4 plus, notice these 2 factorials are going to cancel each other out. So I have x minus 3 squared over 5 squared times 5. And then the next one is negative. Again, these factorials cancel each other out. And so I am left with x minus 3 cubed over 5 cubed times 6. And the last one would be positive x minus 3 to the 4th. Again, my factorials canceled out. 5 to the 4th, 7 times 7, 7, 7, 7. Okay, so that's my p of x. Now they want us to find the radius of convergence for this series. Now, I like to write the nth term. Some of my students were saying that you could just take the derivative, what they give you for the derivative, and divide it by n factorial. Either way will get you your nth term. So our nth term is n is equal to 0, because we did start at 0 with 1/3 to infinity. And I notice that my n factorials canceled out, but it is an alternating series. And at the bottom, I am left with 5 to the nth times n plus 3. Okay? So to find the radius of convergence, I have to do the ratio test. So the ratio test is the limit as n approaches infinity. Now remember, on the AP exam, this notation is important, so make sure you write that, the limit as n approaches infinity. Because it's alternating, we're taking the absolute value, I can eliminate the alternating part. I'm sorry, and then this is x minus 3 to the nth. I left out the most important part. Okay, so this is x minus 3 to the nth plus 1 divided by 5 to the n plus 1 times n plus 4, because I have to add 1 to that. Then multiply by the reciprocal of the original, and that gives me 5 to the nth, n plus 3, over x minus 3 to the nth. And taking the limit of that gives me, let's see, the 5n plus 1s will cancel, and I'll just be left with 5 to the first power. N plus 1, as I'm taking the limit, those cancel each other out. As I'm taking the limit, this will cancel each other out, and I'll be left with x minus 3. So the answer would be the absolute value of x minus 3 over 5, and that has to be, using the ratio test, that has to be less than 1. So the absolute value of x minus 3 over 5 has to be less than 1, which means the absolute value of x minus 3 has to be less than 5. And because my coefficient of x is 1, I can say that the radius of convergence is 5. I multiply both sides by 5, and because my coefficient here is 1, I can say that my radius of convergence is 5. Okay? Now they want us to show that the third degree polynomial, notice it says the third degree polynomial, approximate with error less than 1 over 4,000. Because this is alternating, the error has to be less. If I'm using 3 terms, my error has to be less than the fourth term. So my error has to be less than this term. Because I'm using 3 terms to approximate it, my error has to be less than the next term. So, excuse me. So my error has to be less than the next term, and I'm approximating this at 4. So x would be 4. So this would be the absolute value of 4 minus 3 to the 4th power over 5 to the 4th times 7, which ends up being 1, and we want to prove that that is less than 1 over 4,000. Okay? So doing the math on that, you get 1 over 5 to the 4th times 7, using your handy-dandy calculator, should give you 4375. And is that less than 1 over 4,000? And it is. Okay? Cross multiply, and we see that that's less than. So that is that problem. This problem had a lot of good things. You want to remember that when you're doing the radius of convergence or your interval of convergence, you always want to write this as the limit as n approaches infinity. And technically, well, at this point, I didn't have to write the limit anymore because I had already taken the limit here. So that's why I didn't write the limit here, but I have to show that it's less than 1, which is what I did here. I guess I didn't like saying it's equal to and then say less than 1. So I wrote it here, and then we found our radius of convergence, and then because it's alternating, the error has to be less than the next term. Okie dokie, boys and girls. Let's move on to the next one. This is a problem from your homework assignment. It's number 2 from homework. And here we're using our polynomial e to the x to approximate e to the negative 1. Okay, so we have to recall the polynomial for e to the x. So, e to the x is equal to, this is one of the ones that you need memorized, it's 1 plus x squared over 2 factorial, and we're using 4th degree, plus x cubed over 3 factorial, plus x to the 4th over 4 factorial. okay? So if I'm approximating e to the negative 1, every place I see x, I'm going to replace it with negative 1, which makes this now an alternating series, although we're going to use Lagrange to estimate the error. So this becomes negative x plus 1 over 2 factorial. Now, this is negative 1 squared. I know that, but negative 1 squared is 1, so I was just being lazy there, but I won't be lazy. Plus negative 1 cubed over 3 factorial plus negative 1 to the 4th over 4 factorial. And approximating that, according to my notes, I get 0.375. All right. Now, normally, to find the next error, we would generally use alternating series because this is an alternating series. But here we are asked to use Lagrange. Now, one of the first things you may notice for Lagrange is that, okay, I know n because I used a 4th degree, so I know n is 4. I know c is 1 because x is 1, c is 0 because I'm doing it around the center. So I know that, but what I don't know z, okay? I don't know what value of z, what value is going to maximize the derivative. I do know that the derivative of e to the x is e to the x. I also know that e to the x is an ever-increasing function. So if my maximum value for x, and I'm told here that x can only go between negative 1 and 1, okay? If x can only go between negative 1 and 1, where will its derivative be the highest? Well, its derivative would be the highest at 1, okay? Because this is the function, this is f prime of x. It's an increasing function, and so the derivative is going to be highest at this endpoint. So I can say that z then is equal to 1, and f to the n plus 1, because it doesn't matter how often I take this derivative. I need to take the 4th derivative, yes, but what is the 4th derivative of this? E to the x. So the 3rd derivative, e to the x. The 4th derivative, e to the x. So even though I am looking at, well, actually I would be looking at the 5th derivative, there's a pattern there. So I'm looking at the 5th derivative, it's still e to the x, so what's going to maximize that is 1. So f to the n plus 1 over 1 is what I'm looking at, and then I have n plus 1 factorial times x minus c to the n plus 1. And using the information that I'm given, this is the 5th derivative evaluated at 1 over, because this was n plus 1, n was 4, so this is over 5 factorial times, my c is 0, so 1 or negative 1 minus 0 raised to the 5th power. So my error has to be less than this guy. Okay? So my 5th derivative evaluated at 1 would simply be e to the 1st power. So this is e to the 1st power over 5 factorial times negative 1 to the 5th. But since I'm taking the absolute value of that, it's going to be positive. So that comes out, I think, to 0.023. So that is the maximum error that I'm going to have is 0.023. Now we want this interval such that a is less than or equal to e to the negative 1 is equal to e to the negative b. So once again, my approximated value was 0.375. My error is 0.023. So to find these values, I have to do 0.375 plus 0.023, and then 0.375 minus 0.023. Because what I'm saying is that because this is the amount of error that could be present, this answer will be off by plus or minus 0.023. This answer will be off by the error. So my answer, the actual answer, could actually be, let's start with the smaller one. What is this? 25.352. So it could be 0.352. Or it could be, adding this together, 0.398. It could be somewhere in this interval. And if I actually do it on the calculator, if I actually find e to the negative 1 on the calculator, I know you can't see what I'm doing, but I'm putting e to the negative 1 in my handy-dandy calculator, and e to the negative 1 is actually, as much as my calculator can give it to me, 0.367 or 0.368. So we see that it's within this interval, okay? So this is the actual according to the TI-84 calculator, but we don't know how accurate that is either. But we can see that it's within this interval. Okay? All right, last problem. I have not done this problem yet, so be careful with me as I walk through it. All right, so the first thing I have to do is to write a Taylor series for cosine 2x plus pi over 6. And it's centered at x equals 0. Now, there was some discussion in our PLT as to whether or not we can use a transformation for this. I don't think that we can use a transformation for this because when we do it originally, it is cosine x, and we're not adding. To me, this, even though we're finding it centered at x equals 0, this is centered at negative pi over 6, or actually negative pi over 12. Because it's not centered at 0, I don't think we can use a transformation for it. I could be wrong, but I don't think you can use a transformation for it. But, so we are going to have to do this the old-fashioned way by taking derivatives. Fun stuff. Okay? So we know that f of x is cosine 2x plus pi over 6. So then f of 0 is going to be the cosine of pi over 6. And that is radical 3 over 2. See, this looks fun already. All righty, what are we doing? A third degree? That won't be too bad. So f prime of x is 2 cosine, I think I forgot how to take the derivative. That is negative 2 sine of 2x plus 6, 2x plus pi over 6, which gives me f of prime of 0 is 2 times the sine of pi over 6, which is negative 1. Okay, so my second derivative is negative 4. If I take the derivative of that, that will give me negative 4 cosine of 2x plus pi over 6. And according to my calculations, this is the second derivative. That is negative 2 radical 3. And then the third derivative, finally, we're at the third derivative, is equal to negative positive 8 cosine, I keep doing that, positive 8 sine (2x plus pi over 6). And that evaluated at 0, is 4. Okay? So now I just write my polynomial. I start off with radical 3 over 2, and then it's minus x minus, it's centered at 0, so this would be x plus, no, that would be minus, sorry. This is no longer alternating. So this would be minus 2 radical 3 times x squared over 2 factorial plus 4 x cubed over 3 factorial. Okay. Why do I have that it is a negative? In my notes I have that this is positive. I'm not sure if that's negative or positive. Let me look at it right quick. And I am cheating. So negative 2 sine of, I was evaluating it at 0, so negative 2 of sine of pi over 6. That should be negative because it should be in the first quadrant. Oh, it is positive. So that is positive. Sorry, that should be positive 1. No, that should be negative. I hit the wrong thing. That is negative. Sorry. That is negative because this should be sine of pi over 6 is in the first quadrant, so that's positive. And then that should be negative. And here, cosine of pi over 6 is in the first quadrant times a negative, so that should be negative as well, so they both should be negative. Okay. All right. So this is our polynomial, and we want to know if the Lagrange error bound is less than 1 over 12,000, if we are estimating 1/10. Okay? So, again, our formula is the error has to be less than f of n plus 1 z times x minus c to the n plus 1 over n plus 1 factorial. Okay? So once again, we have to figure out what this is, because we know x. X in this case is 1/10. C is 0. And n, since we took the third derivative, n is 3. So we need to know this ugly guy. So we need to know what's going to maximize that. Well, when we're taking the derivative, so the next derivative of this is 16 cosine of 2x plus pi over 6. That's the third derivative? Yeah, that's the fourth derivative. Because I used 3 derivatives here because it was a degree 3. So this is the fourth derivative. Well, what do I know about cosine and sine? They oscillate, but its maximum value is 16. So no matter what I put in for x, no matter what z is, the maximum value of this derivative is 16. So then I can just say here this maximum, because it's almost like they're telling us f plus 1 of z, that maximum has to be less than or equal to 16, because it will never be more than its amplitude. So that has to be less than 16. So now I can just put 16 into the formula and get over 4 factorial times, we're doing it at 1/10, so x is 1/10 minus 0 raised to the 4th power. And according to my answer here, that is 6.6, repeating, times 10 to the negative 5, which is less than 1 over 12,000. You don't trust me on that? Just do 1 over 12,000 in the calculator, and you'll see that this answer is less than that, because I think this is 8.3, repeating, times 10 to the negative 5. So this is less than that. And so we have proved that the Lagrange bound is less than that. Okay? All righty. So that's it for these problems. Just the more problems you do, the better you are at them. We'll do more free response in class tomorrow, and you'll get it. You'll get it. You can do this. Thank you.